Hey everyone, and welcome back to this class. I created this lecture to answer a question I've been getting a lot recently. As you may have heard, Yoshua Bengio recently announced that development on Theano is going to stop after version 1.0. I posted about this on my website, lazyprogrammer.me, on September 29th, 2017, in case you want to go check out the post. A lot of people have interpreted this announcement to mean that Theano is dead. I think that's a bit of an overstatement, and in this lecture I will explain why. So first, let's talk about why Theano is not quite dead. Well, if you go over to their GitHub page, you'll see that their latest release is in fact 1.0.1. So if you were thinking they hit 1.0 and just dropped everything, you can see why that is not quite right. As of the end of 2017, the latest version is 1.0.1. We have yet to see if there will be releases after this. Secondly, consider what version 1.0 being released really means. In these modern days of open source software, developers are generally very conservative in their numbering. You'll see projects in version 0. something for years, even when there are huge communities around them. Case in point, the latest version of NumPy as of the creation of this lecture is 1.14. The latest version of SciPy is 1.0. The latest version of Pandas is 0.21.1. The latest version of scikit-learn is 0.19.1. These are all libraries that we have been using extensively for years, and half of them haven't even reached 1.0. So the fact that the developers of Theano thought their project deserved a 1.0 release is a huge milestone. This is in fact the most perfect version of Theano that has ever existed, so why not make use of it? It's also important to keep in mind that this is software. Software is code. Code is not like a car, for example. If you don't maintain your car, eventually it will fall apart and it won't work anymore. Code is not like that. Just because you don't maintain your code doesn't mean it stops working. So rest assured, you don't have to be afraid that no one is maintaining Theano. It's not going to break on you. Also keep in mind that pretty much all of the modern deep learning libraries you see today, not including Theano, are heavily inspired by Theano. There are some differences, but many similarities. As you can probably tell from my courses, I am mostly concerned with fundamentals. What do I mean by that? Well, as an example, I believe that in order to teach someone how to add, you have to teach them a fundamental understanding about addition. You can't only teach someone how to memorize 1 + 1 = 2, 1 + 2 = 3, and so on. Addition is a great example because there are an infinite number of possibilities you can have when doing addition. In fact, it is impossible to understand unless you know the fundamental principles. I believe learning all things should be the same way. So when you learn Theano, it's not about the syntax. It's about learning the basic fundamentals of how Theano does things. It's very different from regular NumPy programming. You are not programming with numbers. You're programming with variables. So when you write an assignment statement like A = B + C, you're not assigning the values of B + C into A. In Theano, B and C don't have any values, so that statement doesn't make sense to begin with. Instead, all you're doing is telling Theano how A is to be calculated in the future when you give it values for B and C. That's a fundamental principle that carries over to TensorFlow, PyTorch, CNTK, and so forth. So learning Theano is not about memorizing syntax. It's about understanding these fundamental principles. They easily carry over to other libraries, which are similar in many respects because they were inspired by Theano. Also keep in mind that most deep learning libraries came out much later than Theano. They are still in their very early stages of development. In some cases, that means they don't even have a lot of features yet. For example, array indexing. Easy to do in Theano, not so easy or impossible in other libraries. I go more in depth about these differences in my Theano versus TensorFlow lecture in Deep Learning Part 2, otherwise known as Modern Deep Learning in Python. So if you're looking for a certain special functionality, be mindful that the library you're working with may not even include it to begin with. Another important fact that I've repeated before is that Theano is a great learning tool. It's absolutely fantastic for learning how to code neural networks. This is mainly due to the fact that the syntax in Theano looks a lot like the math you see on paper. As an example, let's look at the equation for a neural network layer and compare it to NumPy syntax and Theano syntax. So not only does it look like the math, it looks pretty much exactly the same as NumPy, which is great because you already know NumPy. So it's very easy to go from NumPy to Theano. The syntax is essentially the same. As an anti-example to this, let's look at some CNTK code. So here's the code for creating the neural network layers and specifying the cost. Here's the code for the training loop, which of course isn't an actual loop because the loop happens internally. So out of this 100 lines of code, where can we even find the equations for a neural network layer? They are in fact nowhere to be found. Let's look at this code for loading in the data. We can see how unintuitive this looks. It's not clear what format the data has to be in for these functions to work, nor is it clear how we can customize these functions for different types of data. This isn't to say that CNTK is bad, I just picked a random example. But it just goes to show that, compared to Theano and what we know about scikit-learn and NumPy, it's not easy to go from one to the other. The most important drawback, however, is that this code bears almost no relation to the theory and algorithms we discuss in deep learning. Theano is nice because there is a smooth transition from math to NumPy to Theano code. It all pretty much looks the same. Everything you see in the math and the pseudocode happens in the actual code. With libraries like this, you end up looking through documentation and trying to figure out what is the right function to call. And as I mentioned before, it may not even exist. So you'll just be looking and looking forever. Finally, let's look at this from a practical standpoint. I use this same example in my lecture about Python 2 versus Python 3 because it's a real example, and if you encounter it, you have no choice but to conform. So consider the situation where you're in a large company making millions of dollars. Clients are paying you to add functionality to your existing product. The more stuff you make, the more money you make. Think about how unreasonable it would be to tell your clients, hey, I'm going to stop working on some stuff I promised you because the devs want to recreate our neural networks in TensorFlow instead of Theano. That sounds ridiculous. To the client, there's no visible effect. As a client, it sounds like you're telling me you want to spend months writing code so that you can replace a neural network with another neural network that gives me the exact same result as the old neural network. Well, firstly, you're not getting paid for that. So your choices are the following. Number 1, continue building with what you have and make money. Or number 2, let your devs spend a lot of time rewriting code that is invisible to everyone except them. Do not get paid anything for it, and in fact lose money because you still have to pay those devs. As a manager or business owner, the choice seems obvious. Continue making money. So the point is, if you're joining a team who has already built their stack using Theano, then that's what you'll continue to use. If their systems are using Theano and they require debugging, you'll have to know Theano very well in order to debug the code. Saying, stop your business for 3 months so we can rewrite all your machine learning code is an unreasonable prospect to say the least. So I hope this lecture has convinced you that immediately shying away from Theano upon hearing that development has stopped is a bit of an overreaction. I hope you can understand the many positives of working in Theano, including how it can actually aid you in learning about deep learning.